This video is to talk about the law of cosines, also used to solve oblique triangles. This is section 6.2, and we'll talk about the case where you're given side, angle, side. Okay, so here is your generic oblique triangle, and there's three versions of the law of cosines. Here is one of them. A squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. It might remind you a little bit of the Pythagorean theorem, and it is a version of the Pythagorean theorem, but it applies to any triangle. So that's why we're saying we can use it for oblique triangles. Okay, this version of the formula is solved for a squared, and you'll notice that angle A is a part of it. Now, you can also use this version, which is solved for b squared, and then the angle involved is angle B, or you can have it solved for c squared, and that uses angle C. All right, so here is a specific example. All right, solve the triangle with the given information. All right, side A is 13, side C is 6, and angle B measures 20 degrees. Okay, so here I've drawn a triangle and just put that information on there. This is where you can clearly see that you do have two side measures, AB and CB, and you have the angle that's included. So that's how you know you have side, angle, side. Okay. All right, so when you're given side, angle, side, start by solving for the side that is opposite the given angle. So our given angle in this problem was angle B. So we'll solve for side B. So we'll use the version of the formula that has b squared on the left. Okay, so then what you want to do is put in the values that you have. So you'll know that b squared is equal to 13 squared plus 6 squared minus 2 times 13 times 6 times the cosine of 20 degrees. And then you pretty much do this in your calculator. The way I like to do it is I usually enter the information for b squared into the calculator, and then I take the square root of the previous answer. That way I don't have to have quite as many parentheses floating around. All right, so in this particular one, you'll get that b squared is approximately 58.4 something. And then here's what we really want. We want b. So b is the square root of that, and it is approximately 7.64 to 2 decimal places. Okay, so here's our situation then so far. We were given those three pieces of information, and then we just figured out side B. Okay, so we have two angles left to find. And in the next video, I will talk about how you can use the law of cosines to solve for an angle. But at this point, we're going to talk about how you can use the law of sines. It can be a little tricky. So I wrote it out in words so that you can hear me describe it, but you can also pause it and read it. So we're going to use the law of sines to find an angle measure. You need to be careful. Our original problem was side, angle, side. So there is only one triangle that will satisfy the given information. Okay. However, when you solve using sine for an angle, there are two possible angles in general, as we saw with the ambiguous case. All right? But side, angle, side is not an ambiguous case. Okay, so when you use or you do inverse sine on the calculator, it will give you an acute angle with the given sine value. Okay. And maybe you want an acute angle, maybe you don't, and it's a little hard to tell from just that. So here's a piece of advice. Solve for an angle that you know has to be acute. And then when you do the inverse sine, whatever the calculator gives you, that will be the answer. Now, how are you supposed to know if the angle is supposed to be acute or not? Right? We have two angles that we're supposed to look for, A and C. How do you know which one of those is acute? Well, if you remember some stuff from geometry, you can reason it out with a little bit of logic. So first of all, a triangle can only have one non-acute angle at the most. Right? If it has a right angle or an obtuse angle, it could only have one of those. Right? It might not have any at all. So every triangle has at least two acute angles, if not three. Right? And so if a triangle does have a non-acute angle, that's going to be its largest angle. And the largest angle of a triangle is opposite the longest side. Largest angle opposite the longest side, just like also the smallest angle would be opposite the shortest side. All right, so in our particular triangle, we know that A is the longest side out of 13, 7.64, and 6. So that means that angle A is the largest angle. So if there is an angle that's not acute, it would be A. So that tells us that angle C, all right, is not obtuse or right, and angle C is acute. So we should solve for angle C with the law of sines. And that's how you would set it up. B over the sine of B, since we know both those measures, is equal to C over the sine of C. And that's what it looks like when you put the numbers in. Okay. And then when you solve for the sine of C, we'll have that the sine of C is equal to 6 times the sine of 20 divided by 7.64. And so then angle C, you find it by doing the inverse sine of that expression, and it is approximately 15.58 degrees. Okay. So 15.58 degrees. And then the last thing you need to find is angle A, which is going to be the easiest thing, since all three angles of a triangle have the sum of 180 degrees. So A is going to be 180 minus 15.58 minus 20. So it's approximately 144.42, which is an obtuse angle.